different terms refer to the same thing or these are different things by recalling your previous memory of software development lifecycle, verification and validation. Hi folks, welcome back to Kiwi Bro. So as I promised, I am back to start our journey to become a full stack quality engineer. The first week, I am going to walk you through some of basics of quality engineering, to give some introduction to quality engineering, to talk about different terminologies, and then we can deep dive into the next topics from the next video. So I want to start with sharing some terminology with you guys. So I'm pretty sure that everyone heard these words. And also I know that some people have some confusion between these terms. Whether does these different terms refer to the same thing or these are different things, like the testing, the quality control, quality assurance, quality engineering, and now I'm talking about some full stack quality engineering things. So whether all these are same or different things, don't worry. At the end of this, you will be full cleared about each of the terminology and there will be no confusions. So before going into discuss about these terminology, I would like to start by recalling your previous memory of software development lifecycle. So I think we need to go back few years in your career or life to your university life. So everyone have learned the software development lifecycle. I think you can remember this, or else don't worry, I will explain it. So the software development lifecycle is like, for example, let's say if you are working on a project. So let's take an example. One of your friends asks you to develop a website for him or her. So then you are the developer. Full project, if it's a small scale project, there will be no other people. So for this example, let's say you are the one who work on all these things. So how do you start this project? So first you talk with your friend and you need to finalize their requirements. So your friend want to build a website. Let's say for the time being it's a static website to make it easy. A static website like their portfolio. So they want to showcase their skills and everything on that portfolio. So you are the one who develops this. So first you talk with your friend and then you get all the requirements. So you need to ask detailed information. So whether does this need to have a form or should it send emails or anything, or just do you need to show their skills and the other information on the portfolio. Likewise, you need to get all the requirements first. Otherwise, if you develop something and then if you hand it over to your clients, in this case your friend, then they will not be satisfied because you have developed something else and what they wanted was something else. There is a mismatch. So to reduce that or to remove that mismatches or anything, first we start with the requirement analysis. So if you do a perfect requirement analysis, you will be able to grab all the requirements what your client needs. After you have finalized the requirements, so if I will start with the waterfall model. So I think it will be easy. So after requirement analysis phase is done, we are moving to the design phase. So design is where you will develop, if you want any databases or anything, you will create database designs and then you will create the other use case designs, the activity diagrams or anything. All these diagrams, designing parts, and also before do the coding you need to do the architecture design. All these design part you will do at this design phase. After the design phase is completed, we can go to the next phase, the development part, where actual development will begin. So you will start coding. If there are any databases, so based on the requirement, so you can think about the other third-party components you need to integrate. If it has any emailing or anything, all these development parts you can do following the designs you have created in the previous phase. And once the development is finished, now we come to the fourth phase of the software development life cycle, which is called testing. So this is one important phase, testing. Keep in mind that it is the fourth phase of the software development life cycle. So at the testing stage, what we do is like we create test cases, then we execute the test cases, then we compare the results, the expected versus the actual result. Then if there are mismatches, that means we have some issues, bugs or issues on the requirements or anything. We need to clarify those. Then we do the reporting, and based on that, if we have any bugs or issues, we can report those, and then again we can go to the development part to fix these bugs, and then again we come back to the testing where we do a retesting to verify whether the bugs are fixed or not. After the testing is finished, that means like all the bugs are, that also depends on how your definition of done. Don't worry, I will talk about all these things in the future videos, but for the time being, for the start for the SDLC, I will walk you through like this. So once the testing phase is done, then we have the last phase, because now the whole development is done, testing is done, the bugs are fixed, and all the requirements are met. So I think we are good to go, right? So now we are in the last phase where we will do the actual production deployment, or we are releasing the product to our clients. So in this case, for your friend, now you can host the website and you can buy the domain and then do the hosting, and now you can ask your friend to go to the website and check that one. So that is the deployment. And then what maintenance? Maintenance means if the client needs more requirements, or if the client has more requirements, or if he needs some changes, so those things will come again. So that's why the software development lifecycle is a circular thing. So there is no ending. It will go on the circle till we have new requirements or we have bugs on the production. So when we have bugs, again we need to go through this. Maybe if it is a critical bug, or if it is requiring again new requirements or changes on the design at the architectural design level or DB design level, again we go to those phases as well. Everything is clear about the bug and it is a normal one, then we directly go to the development, testing, again deployment. So this circle continues till the project is live. So I hope now the SDLC is clear to you guys, and the main thing I need to pinpoint here is the phase number 4 where we conducted the testing. So in the SDLC, now you know testing is a one phase in the software development life cycle. It is just one activity. So now let's move to the terminologies what we have at the beginning. So it started with testing. So testing means, now you know, it is a single step, a single phase in software development life cycle. I hope now it's clear. Next we have quality control. Quality control is also more or less similar to the testing. It is kind of a one phase, or it is a activity in the software development life cycle where we do actual testing or do the executions, and we see whether what we have built is correct, whether what we have built is working correctly. So there what we talk about is about the expected results, the actual results we have. So we do the comparisons, then we make the reports. So we do the comparisons every time about with the expected and the actual. So one issue we have here is like if we have the requirements gathered incorrectly, so in our mind the expected results will be different. For example, okay, let's see. So the client wanted, in our example, the friend wanted to have a form. So when a new user comes to the website and when he fills the form and send or submit, an email should send to friend and another email should send to the one who filled the form, kind of a acknowledgement. But when we take the requirements, we took the requirement incorrectly and we missed that acknowledgement email. So at the testing phase, when we create the test cases, we will not include a step for verifying the feedback email, because on the requirement stage we didn't capture that one. So that is a issue on the requirement phase, but it comes to the testing phase and we didn't capture the issue due to the mismatch on the requirement. That can happen. So keep in mind that example, because we need this example later when we talk about the quality assurance. So I hope now the testing is clear, and as I mentioned, more or less testing and quality control law are both same. And then now we have quality assurance. So as I mentioned previously, testing was one phase or one activity in the software development life cycle. But quality assurance, in that case, quality assurance, from the name also it implies we need to assure the quality. We need to make sure the product has
the expected quality. So the quality assurance is not a single activity or not a single phase. Quality assurance is kind of an umbrella which covers the whole software development life cycle. It will be over the software development life cycle, all the phases. So that means, if you can remember, like here in the software development life cycle, which is started from the requirement analysis and then ended from the deployment, we had 5 phases. So the quality assurance, as I mentioned, it's kind of an umbrella which covers the whole software development life cycle. It's actually a process. Quality assurance is a process where we have different activities or different tasks. We have and also different process. All these things are there to ensure the quality of the product. So it starts from the phase 1 and it will be there throughout the software development life cycle. For example, at the requirement analysis stage. So as a quality engineer, and also one thing I forgot to mention that. So when talking about testing, it was the responsibility of the tester. But when it comes to the quality assurance, since this is a process, not an activity, so this is the quality assurance is the responsibility of the whole team, the whole project team. From the business analysts to developers, the architects, the testers, the quality engineers or the DevOps engineers, everyone is responsible for the quality assurance, or everyone is responsible for the quality of the product or the project they are working on. But the quality engineers are the ones who should drive that. They are the responsible person to do the initiatives, and they are the ones that drive. They are the ones who will actually drive and get the other people involved in the quality assurance. Because quality engineers are the ones who have knowledge in the quality aspects. They are the ones who are more knowledgeable, and also they are the ones who have that thinking pattern, because that from the developer's point of view, they are thinking from on the building. So they will build the application. When they do the testing, the developer testing, or when they write the unit testing, they most of the time they will think on the positive scenarios and they might forget about the negative scenarios. So that's why the quality engineers should be there. There should be someone who thinks from that point of view as well. So that's why quality assurance is a team responsibility, but the driving force should be the quality engineers. Okay, so let's go back to the previous example I mentioned where I stopped. I said when we do the requirement analysis, we missed some requirements. We captured those incorrectly. So in that case, when we come to the testing phase, we didn't capture the actual bug, because in our requirement document, we didn't have that requirement. So we are creating our test cases and doing the testing based following the requirements we have gathered. So if that was missed on the requirement, then it's missed on the requirement document, then we missed it on our test case, then it was released to production, and now we have a production issue or a bug. So that's why this issue was there, because we had testing at only one phase, which is the testing phase or the phase 4. So that is the difference between testing and the quality assurance. So if for this project, if you have quality assurance, then from the requirement analysis phase, we will think from the quality aspect. So when the business analyst working on the requirements, then we can incorporate few things like reviews, and then also the quality engineers also can review the stories or the SRS documents, any documents we have, and also within the business analyst they can do the reviews for the documents. Then they will find some issues. When we have the requirements, then we can do brainstorming with the whole team, because then different people give different points from their point of view. Developers will see it from the technologies they are going to develop, and from that point. Testers will see it from the testing side, so they can give their feedback. Likewise, everyone participate there. So in that case, we can find the issues early. So testing begins at the very first phase, at the requirement analysis. Testing here means we don't have any product to test, but still, even the requirement we have tested. Then if we can catch any issues at this phase, then it is very easy to fix, because we haven't started any development work yet or any testing. So then we just need to update the requirements document and then get the customer feedback, and then based on that we can start the design and development and testing. So that's why. Then when we come to the design phase, so the developers will create the database designs, architectural designs, and the other diagrams like the use case diagrams or anything. So then within the developers, they can do review. And also quality engineers can use those designs to create their test cases as well. And at that time also, we may able to find some issues. So that is how quality assurance will be catering at the design level. Then when it comes to development, developers, once they have finished development, they will ask for peer reviews. So their subordinates will review. So that is one type of quality aspect. Then they can create unit testing. So there's no need to wait till the quality engineers start their testing. From the developer side, they will do developer testing, and also they will create unit testing. So at that time also we can capture some issues. Then it comes to the testing. So the normal phase, as I mentioned previously. So at the testing stage, we do the functional testing, non-functional testing, manual automation. Likewise, all the testing will be done. And then at the deployment and maintenance phase, and at that phase also, we can do different types of reviews. We can have audits. All these things will come into play. And also, since now we have the process, then time to time we can do some audit to check whether the team is following this process or not. So audit is also come under the quality assurance process. Though testing was the one phase on the software development life cycle, quality assurance is covering the whole software development life cycle throughout the requirement analysis, design, development, testing, deployment, and at all the phases. So that's why, so if we check this diagram, so we can say testing is a subset of the quality assurance. That's correct, right? Because quality assurance is the whole process, which also has the testing stage as well. So in that case, testing is a subset of the quality assurance. I hope now it's clear the difference between testing versus the quality assurance. Then we have quality engineering. Again, quality assurance, quality engineering are like more or less they are referring to the same thing. So testing and quality control versus quality assurance and quality engineering. So those are the four terms which are mostly used. So I hope everything is clear to you guys up to now. And if you have any issues, use the comment section below. And also you can drop me email at qvbro.pro@gmail.com. I will check all your queries and I will try my best to answer everyone. So next we have the new term, what we need to pin here, the full stack QV. So who a full stack quality engineer is? So we know about the quality engineer. We have different types of quality engineers based on the tasks they do. We have manual engineers who does the testing manually. Then we have automation engineers who work on creating automation scripts and the automation work. Then we have performance test engineers who work on doing performance testing of the application. Sometimes we have accessibility testers as well who work on the accessibility side. And we have mobile testers. Likewise, there are different roles. So a full stack quality engineer should be able to work on all those areas. The full stack quality engineer is capable of doing manual testing, is capable of doing automation testing, is capable of doing performance testing, mobile testing, accessibility testing, security testing, and anything. So that's our ultimate goal, to become a full stack quality engineer. Okay, since the terminology is clear now, let's go to the next. Okay, here I have two phrases, verification and validation. So verification means building the product right, and validation means building the right product. So these two come with terms we discussed earlier, testing and quality assurance. Testing, again, let's recall our memory. Testing means we do the testing and check whether the application behaves accordingly, whether it results the correct output as we need, the expected output and the actual output. So that means we are testing whether the product works correctly. That means validation. We are doing some validation task there. We do the assertions to validate the output, whether the actual output is equal to the expected output. The assertions we do. That means we are validating the output against a base. So that is called validation. Building the right product. The right product. Next we have verification. Verification goes with quality assurance. That means every time we are verifying. That is more towards the process. We are verifying whether we are following the correct process, whether we are doing the right activities. It's not about the output like the validation. Validation, every time it doesn't matter how you do that. How you do the task is not considered under validation. The most important thing in validation was the output. But under verification, we are not talking about the output. We are talking about the process, or how you do the tasks, or how you build them, building the product right. So that is verification. If you do verification correctly, most of the time there is no need to do the validations, because if you follow the process correctly, all these issues have been caught early. So if you followed all the best practices and everything, so there is less chance to miss any issues or have any issues. But still we need to do the validation at the end. Verification is not enough, because under the quality assurance I mentioned, the testing was a subset. Though we did quality assurance, we can't skip the testing part. It's a must. It's a subset under the quality assurance. So we can't have only one. So we need to go with both, verification and validation. If you have more verification, that means you are doing the quality assurance right. You have a proper process and everyone is following the process. And then now you can do the validation, where you test your actual product and see expected outcome versus the actual output. So keep in mind those two terms, verification and validation. Okay, this is one important thing. So we all talk about testing, the quality engineers, everything. So do we actually or really need to test? Because like we know we are in a changing world, then we have very limited timeline for our product or the project, because our competitors will release projects soon before us. So that means we will lose some customers, right? So there is a competition. We should try to release before them, or we should try to give the best to our customers early. Otherwise, if we are getting late, means we will lose some customers again. But we can't think only about the timeline. We need to think about the quality as well. Let's say there are two companies who are the two competitors working on a similar product. So the company A wants to release their new feature before the other company does. So without doing much testing, so they wanted to reduce the time at the testing level, because the requirement gathering, those things, they will fast track, but they can't skip. So the development, it's a must. Without development, we can't release anything. Okay, then when it comes to testing, they gave only very short period to do the testing. They fast tracked that, they skipped so many things, and they just wanted to release it. Okay, let's say they released it. But when it's in live, now when clients want to use the product, actually it's not usable. So there is no point. So when customers try to log in, the login fails for different customers, because these things not properly tested. And also when the high load is there, the servers going down, no performance testing done, and there are so many security vulnerabilities, customers' data is in risk, right? There are so many issues. So even though they released it first, I don't think that they will gain any advantage from that, because even though the feature was available, it is not usable. So what's the point? So that's why quality is important. When we have low quality in our product, customers will lose their trust and satisfaction towards us. And also again, when there are some issues like the security vulnerabilities or anything, if someone hacked us and if they get our data and if they release those, then we have to face some lawsuits as well, right? Law regulations, those things also we need to face. And then if the performance issues are there and the system goes down, again customers can't use. So likewise, there are so many issues. So that's why testing is important. So as I mentioned, if we have the quality assurance, which means like we are trying to cover the whole software development life cycle from the very beginning, not only at the testing phase. So we can identify these issues early, and then we can fix those early. Fixing the issue early means it will save our cost and time. But how? Let's say after we go this whole cycle and we have released our product. Now at the production, customers are facing some issues and they are reporting it to our customer service, as now it comes as a production bug. Then we need to go through that whole cycle again, through the requirement analysis, design, development, testing, and again we need to go through deployment and then release. That means a whole cycle. It will take time. All business analysts need to be participated there, then developers, testers, DevOps engineers, everyone need to be available to that. So that means manpower, man hours. So company need to pay that. So that is why time and money. But if we identify that issue early, maybe let's say at the testing phase, at least the phase 4. So requirement analysis was done, design development was done, and when it comes to testing phase, we identify the issue. Still we haven't released it to production. When it was captured at the testing phase, now we report the bug to developer, they fix that, and we do a retesting. Just go back on the phases and come again to testing, and then retesting to validate issue is fixed, and then we deploy. Again, let's go back. It was captured at the design phase. So now very easy. The architects or anyone who are working on the design, so they can update the design, and based on the design we can do the development. So that's why. If we can capture these issues early, it will save cost and time both. And then also when we do more testing, that means we identify more issues and then we fix those issues and then we do the release. That means we have improved product quality. If we fix more issues means there's less chance to identify issues at the production. That means like less issues were released to production, because most of the scenarios we captured at early at the lower environment and we fix those. So that means improved product quality. So if the product quality is improved, so when our clients and the customers are using that, they will face very low issues, very low number of issues. So that means our customers' trust and satisfaction is high. So just imagine if you want to go to your favorite social media application, and when you try to post something and it fails, how would you feel? But when you log into your application and you do your normal activities, then you can achieve those. And let's say, and also we have like 99% of uptime. So you are very satisfied. So that's why. Improved product quality means the customer's trust and satisfaction is high. If there are no security breaches happened, so then customers have faith on your application, so they have nothing to fear about their data at your site, likewise. And also it will reduce the level of risk. If you have done testing, so then when you do the release, okay, you know how much of percentage you have tested. So then if all the critical issues or blockers are fixed and released, then from your side also, from the project team side also, you are very satisfied, you have faith on that, and then you can think the risk is reduced. So those are some important facts of testing. And also you have sufficient information for the stakeholders, like the product managers, project managers, the business side. So you have sufficient information for those stakeholders to make their decisions correctly or wisely. So based on this information, okay, let's say after doing the testing, the quality engineer will share the report. It says like, okay, we have 3 blockers, the email functionality is broken, so this is related to a new feature we are going to release soon. So now the business team, the stakeholders can make their decisions whether should we deprioritize other work and prioritize fixing this first and then do the release, or are we going to release this with some known issues, likewise. So they can make their decisions correctly if they have sufficient information. So that's why testing is very important. Otherwise they will make decisions with insufficient information and it will cost later. So I hope these things are clear now. You know why testing is important and why you need to conduct testing and why you should not skip testing due to the other reasons. Then when it comes to quality engineering, there are some principles. There are 7 principles. The first one is testing shows the presence of defects. So as I mentioned, when you do more testing, you will be able to identify more issues at lower environment. We do testing to identify the issues, not the other way. We do testing and we say, okay, we didn't identify issues, so that means the product is bug free. No, that's not. We do testing to identify bugs and to fix those, not to blame anyone. So testing shows the presence of defects. When we do more testing, we can identify more issues. That means we can fix those early. So that is principle 1. Next one, exhaustive testing is impossible. What is this? Exhaustive testing, or in some other words we can say 100% test coverage is not possible. But now it's like contradict. What I said previously is do more testing, find more issues. Now I'm saying 100% of test coverage or exhaustiveness testing is not possible. Why? Because it's based on, again, on the timeline and everything, right? We have a short period, but that doesn't mean like we release without testing. So that's why where you need to wisely identify the scenarios you need to test. So that's where we talk about test design techniques. Don't worry, I will walk you through those things in next videos. So, okay, let's take another example. We have a form where there are 5 fields. Each field accepts integer number from 0 to 100. So you need to set values for each 5 fields and click the submit button. Based on that, it will do something. So here, how many possible scenarios are there? For the first field, you can put anything from 1 to 100. That means 100 possible values. These are just the positive scenarios, and then you need to add negative scenarios as well. Okay, just forget about the negative scenarios. For the first one, there are 100 possible ones. For the second one, again 100, likewise 5. Then there are combinations as well. Because, for example, for the input field 1, I put 1, second input field 1, third input field 1, fourth input field 1, and fifth input field I put 2. Likewise, we can change and make combinations. So then how many combinations? I think 100 into 100 into 100, likewise 5 times. So how many test scenarios? Just for this form. That's also only the positive scenario. So that's why I am saying exhaustive testing is impossible. So then the quality engineers need to wisely identify the scenarios, what to test. So like we just can't pick random things, because then the test coverage will be reduced. For example, okay, 5 positive integers between 0 to 100, and for each field like 3 scenarios. For example, I put 5 to everything and submit and check it passed. Then I put 50 to everything and check passed. 80 to everything and check pass. So, and I say, okay, I checked, verified 3 scenarios and it worked as expected. But we haven't checked negative scenarios. We haven't checked, try to input letters or any negative numbers or anything bigger than 100 or any special characters, right? So we didn't click the submit button without filling these input fields. Likewise, there are some negative scenarios as well. Those need to be also tested. Likewise, if you check like all the possible scenarios, then we can say the test coverage is high. So that's why you need to wisely identify your test cases. So that's why we have test design techniques, and we can discuss that in the next coming future videos. Then next, the third principle is early testing. I hope now you have clear idea about this one. When we discuss about the quality assurance, I explained this one. If you can identify these issues early at early phases, so then it will easy to fix, and also it will lower your cost and time as well. Next one, the fourth principle is defect clustering. Under defect clustering, we can talk about another principle called the Pareto principle. The Pareto principle means 80% of output depends on 20% of inputs. So this is a general principle, not directly related to the quality assurance, but we can use this principle as well for the defect clustering. So how can we map this to quality engineering or software domain? So we can say like 80% of bugs will caused by 20% of the modules or the component. So if you do the clustering, so when you do the testing and when you identify issues, you can maybe, if you are using Jira or something to report your bugs, so you can add the component. For example, let's say email. So the same example of your friend. Dashboard is one component. The email, let's say email sending module is there, that is one module. Then the login, likewise you can have different components. And then if you cluster these, if you group these bugs you have identified, then you can check the Pareto principle. So most of the time you will see 80% of defects you have identified are coming from 20% of the components, or from 20% of your modules will cause the 80% of the bugs. So that is called the Pareto principle. So if you do this clustering wisely, if you have less time to do the testing, so then now you know what are the components where you need to put more effort to testing. So that's how, based on these things, you can think what are the areas where you want to deep dive into and do more testing. Likewise, you can identify. Okay. Then next one is called the pesticide paradox. The pesticide paradox means, I hope you know about the pesticide. So when we do the farming, so when we put the fertilizers, likewise we do the pesticides to get through of these, the bugs and everyone, the actual bugs, not the software bugs. So, but let's say for a couple of years we are using the same pesticides, then these bugs will get used to that. So then there's no point of applying the same pesticide over and over, because now these the bugs and everyone is now used to those, and there is no effect on them. So even though you apply the pesticides, so you can see the bugs are on their field, on the farm. So then you need to maybe change the pesticide, then it will have effect on the bugs. The same thing. If you are following the same tests over and over and over again, so now you will not be able to identify new bugs from these test cases, because let's say you have only 20 test cases. So first time you run these 20 test cases, okay, now you identify 5 bugs. Okay, now developers fix those 5 bugs. And after some time, again, when you get the release, you run the same 20 test cases. Then you will identify 1 or 2 bugs. Again, those are also fixed. Likewise, again another cycle, you are following the same 20 test cases. Now you will not identify any bugs. It's the pesticide paradox. So you need to update your test cases as well. With time goes on, you need to update your test cases. There's no point of running the same test cases over and over and over. Okay, next, the 6th principle, which is called testing is context dependent. So we don't test e-commerce application in the same way where we test flight simulator application. It depends on the context, the tools we use, the technologies we use, how we do, or the process, how the approach is taken. Everything is depend on the context. We can't test a banking application in the same way where you test SMS gateway. It depends on the domain as well. Domain specific things also need to be tested. So if you are working on the telco platform, application related to telco platform, then we are not using these HTTP protocols. So you need to learn those specific protocols which has been used in these domains. Then based on those, you need to create your test cases and do the testing. Those scenarios you need to cover. Under testing, I mean the process, the tools, the technologies, the approach, everything. Everything is context dependent. So the last principle is absence of errors fallacy. So that means, like, if you do testing and if you didn't find any issues, that doesn't mean that the application is bug free. So then you need to keep in mind. Then again, I have 2 important phrases. So these 2, like based on the 7 principles we discussed, now I think this will be more clear to you. These are kind of some myths in the software industry. We will say like we tested 100%. No, it's false. I explained it why. 100% test coverage is impossible. It's not possible anytime. 100% test coverage. And also there's a myth. We say the system we tested thoroughly and it's bug free. No, there are no bug free software in this world. Even the Windows, Facebook, Google, Twitter, all these applications have bugs. In production, yes, there are no bug free software. Then why do we do the testing? So if I say there are no bug free software, then why do we actually need to spend time for testing? I mentioned that earlier, right? Why testing is important. We do testing to discover the bugs or identify the bugs. Then we fix those early and then do the release. When there are less production issues, the customers are also happy, right? So we can't remove all the bugs, but we try to do is we do testing to reduce the bugs which will lead to the production. So there are no bug free software, yes, but we need to make sure we try to cover all the possible scenarios and then we don't miss much issues, and then there are lower number of issues in production when compared with the issues we have identified at the lower environment. So those are the things which I wanted to talk for today at our day 1. I don't want to put more information for you and to overburn you. I know the day 1 was a bit boring because all the things we discussed were related to some theoretical things. There's nothing hands-on experience things, but don't worry. If I didn't cover these parts and if I just jumped into some tools or technologies things, then you are starting without the correct base. So as I mentioned, I want to go this journey with you from the beginning. So then if we have this knowledge, then it will be easy for us to carry forward our journey. So as I mentioned previously, so if you have any questions, please feel free to shoot at any time. So you can use the comment section, or else you can drop an email at qvbro.pro@gmail.com. I am really happy to help you with all your questions. So then let's see with our next video on another topic for full stack quality engineering. See you till then. Happy testing.
you.